I am too smart. I am too smart. S-M-R-T. I mean S-M-A-R-R-T.
All right, everybody, welcome to day 4 of the notes on right triangles and trig. Today we're going to look specifically at trigonometry. Okay, trigonometry sounds complicated, but it's really just the geometry of triangles, and we're going to look at the simplest kind of trigonometry, which has specifically to do with right triangles. I'd like to welcome my 4th block class. It's going to help us out with the notes today. So when you hear things yelled out in the background, it's not just me and people that I've made come in the room and locked them in to answer math questions. So a ratio is the blank of two quantities by division. I'm going to give you this one here because this is a specific thing we're talking about. It's just the comparison. Okay, a ratio is the comparison. I can't spell. Of two quantities by division. And when we say by division, when we see the word ratio, we need to think fraction. Okay, we're going to have a fraction. Okay. An example, what is the ratio of the leg of the length of the long leg, the length, and we're talking about this triangle, what is the ratio of the length of the long leg to the length of the shorter leg? Yeah, it's a 5, 12 over 5. Okay, so 12 over 5. What is the ratio of the length of the shorter leg to the hypotenuse? 5 over 13. Okay, 5 over 13. So far, so great. All right. All right, so there are 3 trigonometric ratios. Okay, there are 3 ratios that we have to know for this class. Those ratios are the sine of angle A, and when it's capitalized like this, that's an angle. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. The most common way of remembering this, is using the mnemonic device SOHCAHTOA. I'm fairly certain that Sacagawea had like a half-sister. You'd have to ask Mr. Hampson or one of those history people about that. And the half-sister's name was SOHCAHTOA. It's a little bit of trivia there for you. None of that's true. Okay. No. So we can remember SOHCAHTOA. That helps us understand the relationship. When it's sine, it's the opposite over the hypotenuse. Cosine, it's the adjacent over the hypotenuse. Tangent, it's the opposite over the adjacent. So we're going to look at that a little bit more specifically on this page right here. So the sine of angle A is the measure of the leg opposite to angle A over the measure of the hypotenuse. So the sine of angle A is, and what's a really good idea is if we're talking about angle A, label the sides. Adjacent means next to, so we have the side next to it, the side opposite, and the side and then the hypotenuse. So the sine of angle A for this model would just be A over B. The sine of angle B is the same as the sine of angle A as far as the relationships. It's the opposite side of the side opposite to B and the hypotenuse. So the sine of angle B would just be B over C. And I don't know why I put B here. Sorry about that. Okay, so that's the sine relationships. Sine always has to do with opposite and hypotenuse. The cosine relationships, the measure of the adjacent leg to angle A and over the measure of the hypotenuse. So the cosine of angle A, and again, this is adjacent, this is opposite, this is hypotenuse. Let's go back for one quick second, so I'll do this in a different color. If we were talking about B, the hypotenuse is the same, but now the opposite and adjacent have switched. Okay? When we look at the cosine of angle A, okay, it's the adjacent side, so right next to it. Remember, my O, A, and H have nothing to do with these A, B, and C. I'm just labeling opposite, adjacent, hypotenuse. So the cosine of angle A is B over C. And at the same time, if I change, and I'm looking at the cosine of angle B, these are still the same, right? Opposite and adjacent. Or sorry, adjacent and hypotenuse. Angle B Here's the opposite. This is still the hypotenuse. This is the adjacent. The adjacent side to angle B is A, and the hypotenuse is C. Okay. Tangent is the measure of the leg opposite to angle A over the measure of the leg adjacent to angle A. And it's the same for the relationship with B. Okay? So let's take a look. If we're talking about angle A, I'll label my opposite adjacent hypotenuse. So it's this opposite side right here and this adjacent side, so it's just A over B. If we're talking about the tangent of angle B, it's the opposite and adjacent, and there's the hypotenuse. It's still just, it's opposite over adjacent, so it's B over A. So those are the trig ratios that you have to know. Okay, and again, we use this word right here, SOHCAHTOA, to remember it. My suggestion would be every new page, everything we do today in the practice, to just continually write SOHCAHTOA, SOHCAHTOA over and over and over and over. And by the time we get done with class today, you'll have memorized it. All right, so let's take a look. If we just want to set up the correct trig function, all we're doing is setting these up. So we're going to practice our relationships. Go ahead and pause the video right here. Work your way through these 12 setups. We're just looking for the fraction. That's all we want. Okay, go ahead and pause the video, and then we'll check our answers. Pause it now. All right, here are your answers for these problems. If you have any questions about these, make sure you see your teacher. But we tried to really label the hypotenuse and the opposite and the adjacent depending on which angle we were talking about. So there you go. Let's take a look here. So types of questions you'll need to deal with involving right triangles. Now, you're given a certain acute angle measure. You have to find, as a decimal, the sine, cosine, or tangent ratio in relation to that given angle measure. So, for example, we have problems like this where we're just asked to find the tangent of 50. This is where we're going to use buttons on our calculator that you've never really used, not productively anyway, or that you've never really used before. So you're going to take your calculator. A really important thing to do in both a TI and a Casio. Everybody in my class has a Casio, so I'm only going to show it in that. If you have a TI, we can show you really easy how to do this. We're going to go to the run menu, okay, so number 1, and then I need you to hit shift menu. You're going to scroll down to the angle. The default is a different kind of angle measure called radians. We don't want radians. We're going to work in degrees. So I need you to choose F1 to change that to DEG. Otherwise, you'll get every single answer wrong. So if you didn't just push those buttons, rewind the video and push those buttons. Then just hit execute or enter, and now we're ready. So the first one, it's just tangent of 50. All I have to do is push tangent 50, enter. And that's it. The directions say to round it to 4 decimal places, so that would be 1.1918. 1.1918. It's just that easy. Pause the video right there. Get answers for 2 and 3. Go. All right, so there are the correct answers for number 2 and 3. Hopefully you got those with little to no problem. Let's take a look at what other kind of questions we'll see. Sometimes we'll have a variable that is on top of a ratio. So, for example, we'll set up number 1, and then you'll do 2 and 3. The first thing I do when I get these problems, I look, all right, so here's the angle I'm talking about, and then I'm going to label the sides. There's the hypotenuse, there's the opposite, and there's the adjacent. Then I'm always going to have SOHCAHTOA written on my paper. So then I have to look at this and determine, all right, I'm given the A, okay? I have a variable for the O. So then now I know that I have A and O. Well, which of the trig functions allows me to use A and O? Tangent, exactly. So I'm going to set up my equation now. The tangent of 42 equals opposite over adjacent. That's x over 9. Okay? All we do now is cross multiply. This is actually over 1. X times 1 is x. And then all we do in our calculator is the tangent of 42 times 9. We literally just put it in exactly like that. Tangent of 42 times 9. And so for this missing side, we get, and the directions say to the 10th, 8.1. And that's it. Go ahead and pause the video, see if you get answers for 2 and 3. All right, so there are your answers for numbers 2 and 3. Hopefully you got those. If you didn't, check and make sure that your setup is the same as ours. Here's our setup for number 2 and our setup for number 3. Usually the mistakes are made either with the setup or there's some sort of calculator error. All right, let's take a look at what's next. So sometimes our variable is on the bottom of the ratio, and that doesn't really change anything other than one step in how we solve. So let's take a look at number 1. Here's my angle. I have the opposite, the hypotenuse, and the adjacent. So I know that I'm going to use sine. So I have the sine of 40 equals 39 over x. Okay? When the variable is on the top, we multiply. When the variable is on the bottom, we divide. That's the only difference. X equals 39 over the sine of 40. Now, if you want to know how I'm getting that, it's really quite simple. I'm still cross multiplying. This becomes x times the sine of 40 equals 39 when I cross multiply here. Then I divide both sides by sine of 40. These divide out to 1. I just have x, and now 39 divided by 40. And then same thing in my calculator. 39 divided by the sine of 40, and we get 60.7. X equals 60.7. Go ahead and pause the video. Get numbers 2 and 3. Pause the video now. All right, so there's the correct answers for number 2 and 3 for when the variable is on the bottom of our proportion. Hopefully you got these answers here and here. Okay, so sometimes we're given as a decimal or a fraction the sine, cosine, or tangent ratio in relation to an unknown angle. So we have the ratio or we have the decimal. We just don't know the angle. Here we're going to use what's called the inverse function in our calculator. We use the inverse of sine, cosine, and tangent to find the angle. Okay, sine to the -1, it looks like here. That's not like an exponent. That's when we're taking the inverse. It's undoing the problem for us. And here's what that looks like. When we have a problem, like for example here, use the figure below. What is the measure of angle y? So we want to know the measure of angle y. Well, what we can do, we're gonna work our way through this, and it'll kind of explain the problem for us. Circle the links that you know. Do we know the hypotenuse? Do we know the side adjacent to y? We know that that's 41. The side opposite to y, do we know that one? We know that that one's 100. Okay? Cross out the ratios we will not use. Will we use, I think labeling is always better, so this is hypotenuse, opposite, and adjacent. So can we use sine? Well, sine has an h, and we don't know an h. So we're not using sine. Can we use cosine? Cosine has an h, and we don't know the hypotenuse. So we are going to use tangent. Underline the correct word to complete the statement. If you know the sine, cosine, or tangent ratio of an angle, you can use the inverse. Okay, we're going to use the inverse. It said underline, and I circled, so look at me. So we would use the inverse in this situation when we don't know what the angle is. So here's what would happen next. Follow the steps to find the measure of angle y. So step 1, we said that we were going to use what? The tangent, right? We're going to use the tangent. So the tangent of y equals blank over 41. What was the other thing? 100. Okay? Now we're going to use, instead of we can't take the tangent of something we don't know, so we can put it on the other side simply by taking the inverse tangent. Okay? So all we're going to do is we're going to go into our calculator.
Put on your turntable.
Okay? You'll notice that above the tangent button is a little tangent -1. So all we have to do is we're going to hit Shift Tangent. Then in parentheses we're going to put 100 divided by, or I can put it 41. That in parentheses. Hit Enter. We'll say let's go ahead and do this to the nearest degree. We'll call that. That's it. So when we're looking for the angle, we're going to use the inverse function. Okay? Let's take a look at one more, and then you'll do these other ones on your own. This one, for number 1, they told us the sine of P is 0.1239. So capital P, we're looking for the angle. So I hit shift, sign. Then I just put in 0.1239. Enter. The answer is, where do we want to round? To the nearest tenth, 7.1 degrees. I'll do number 4 also, just so we can make sure we're on the same page. This is adjacent, this is opposite, this is hypotenuse. So we have sine of x equals 3/9. So again, in our calculator, shift sine, 3 fraction 9, enter, 19.5. Go ahead and pause the video here. Do 2, 3, 5, and 6 on your own. Ready, go. There's our answers for 2, 3, 5, and 6. The rest of the notes is practice for you guys. We'll work on that next time. If you have any questions on this, make sure you find a spot to write them down so you can ask. See ya.